Hello and welcome students. In the last video lecture I had started chapter number 2 of statistics, that is presentation of data. In that we had studied illustration number 3 and illustration number 4, and also we had discussed in the previous video lecture how to convert inclusive frequency distribution into exclusive, and we had also discussed how to find the mid value of each of the classes. Okay, now today we are going to understand one new topic of this chapter, that is cumulative frequency. Now cumulative frequency means what? Cumulative frequency means whatever the frequencies that has been given to you in the question, you have to do the addition of the subsequent frequencies. For example, I am giving you, that is, suppose first frequency is 2, 3, 5, 7. Like this way the frequencies have been given to you in the question. Now if you have been asked to find the cumulative frequency, cumulative means combination, combining of all the frequencies, subsequent frequencies. So over here the first one is 2. So 2 plus 3, that would come to, first one that would be 2, and afterwards 2 plus 3, that would be 5, 5 plus 5, that would be 10, and 10 plus 7, that would be 17. Always the cumulative frequency, the last cumulative frequency would be equal to the total of frequency. Over here, see, 2 plus 3, 5, 5 plus 5, 10, 10 plus 7, 17. So the total of frequency that came to 17. And the last cumulative frequency, that is also 17. It means the last cumulative frequency and the total of frequency, that should always be equal. Okay, so that's the concept of cumulative, means combining of all the subsequent frequencies of all the classes step by step. Okay, now after understanding the cumulative frequency, we have to understand two topics in that cumulative frequency, that is less than type and more than type. Now how to find the less than type cumulative frequency and more than type cumulative frequency? For that, one practical sum that I have taken from exercise number 2.1 of your textbook, that is on page number 36. So while referring this video lecture, you keep your textbooks open so that you can understand the question while the practical solution is there on the board. Third question that I have taken, the data regarding the number of mobile phones produced during last 60 days by a mobile phone manufacturing company is given below. Mobile phones that are produced during the last 60 days, the data has been given to you. Distribute it into 10 classes. It means over here it has been clearly mentioned that you have to convert the data into continuous frequency distribution. Already we discussed, if the data is small or if the range is small, then discrete frequency distribution is more appropriate, and if the data or if the range is very wide, at that time continuous frequency distribution is more appropriate. Over here it has been clearly mentioned that whatever the data that has been given to you, it is to be distributed in 10 classes. So it is clear that we have to distribute it into classes, means continuous frequency distribution. Okay, now for that, first step is to find the range. We have already discussed in the previous video lecture how to find the range, that is highest value minus lowest value, okay, or maximum value minus minimum value. So you can see I have shown the calculation over here, that is range is equal to xh minus xl. xh means highest value of x and xl means lowest value of x. Okay, so highest value you can see from your data that has been given in the question. Highest value, that is 1029 and the lowest value, that is 188. Okay, so highest value minus lowest value, difference that comes to 941. Okay, so range is 941. So from the range we have to decide the class length. Okay, so for class length, this formula also we had discussed in the previous video lecture, that is class length is equal to range upon number of classes. Range upon k. K means number of classes. Okay, so C, that means class length is equal to range. What range we have got? That is 941. 941 divided by number of classes. Already that has been given in the question, that is 10 classes. So 941 divided by 10 is equal to 94.1. Now 94.1, that is the class length. So generally we don't take it in decimal, we generally take it in multiples of 5. Okay, so over here 94.1, so nearby it would be 100. Okay, so So we have taken the class length to 100. So difference of 100 will be keeping in between of each of the classes. Okay. So over here you can see the first class that I have taken, that is 100 to 199, because the lowest value, we had already discussed that the first class should always include the minimum value. Over here what is the minimum value? That is 188. So in the first class, whatever we are deciding, it should include the first value or the minimum value, that is 188. You can see 100 to 199, 188 will already be coming. That's why the first class, that is 100 to 199, it means the gap of 100. Okay. Then afterwards 200 to 299. Then afterwards 300 to 399. Once you get the first class, you will get all the subsequent classes because the class length is equal, that is 100 in between all the classes. Okay. Now up to where it should be extended. It has been told that 10 classes you have to make. Okay. So naturally 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 classes that we have to continue it. Okay, and the last class should include the maximum value. Just as first class should include the minimum value, in the same way last class should include the maximum value. You can see the maximum value that has been given, that is 1029. Okay, so in the last class, that is 1000 to 1099, 1029 would be coming, right? So the last class should be including the maximum value of the given data. It means the number of classes that we have set. Okay. Now after deciding the number of classes and the class length of each of the classes, let's do the tally marks. That you can do it very easily by just putting the marks according to the data that has been given to you. Suppose it is given to you 255. So you can easily understand that it will be coming in the class, that is 200 to 299. So just you have to put one vertical lines. After 4 vertical lines, the fifth one you have to do the slanting line. So in this way you have to count the frequency after getting the telling. So, okay, so over here you can see there are 2 lines. So 2, 4, so here 4. So in the same way you have to count the frequency. Already we discussed that whatever the frequency total that is coming, that should be equal to the number of data that has been given in the question. Over here we shall count it. 2 plus 4, that is coming to 6. 6 plus 9, it would be coming to 15. 15 plus 7, it would be coming to 22. 22 plus 10, it would be coming to 32. 32 plus 8, 40. 40 plus 9, 49. 49 plus 4, that would be coming to 53. 53 plus 3, 56, and 56 plus 4, that would be coming to 60. Okay, so whatever the data that has been given to you, that are of the 60 days data of the mobile phones. So the total of frequency should also be coming equal to the number of data that has been given to you in the question. It means our frequency is correct. Anywhere we have not missed out any of the frequency. Okay. Now, after getting up to here, you have already studied in previous video lecture also how to do telemarks, how to find the frequency. Okay. Now, the new step that we are going to study, that is today less than type and more than type. Okay, it has been asked. See, last in the question you can read. Obtain less than and more than type cumulative frequency distribution from it. It means from whatever the data, you have to find the less than type and more than type cumulative frequency. So that when we can find out, when we get the frequency. So first step was to find the frequency. After finding the frequency, we can find the less than type or more than type cumulative frequency. Okay. So after finding the frequency, the first step, that is less than type, and second one, that is more than type. Now less than type means less than upper boundary point. Less than type means upper boundary point. Make it clear. For finding less than type, the value that we have to take, that is less than upper boundary point. And for finding more than type, we have to take greater than or equal to lower boundary point. Again repeating, easy to remember. For less than type, upper boundary, opposite to it. Less than means upper boundary point and more than means lower boundary point. Less than means upper boundary point, more than means lower boundary point, opposite of the other two. Okay. Now, first one we have taken over here 99.5. Now students, whatever the data that we have found the classes that are inclusive or exclusive, that are inclusive frequency distribution, because you can see the first upper limit of the first class and the lower limit of the subsequent class that are not equal. If they are not equal, it means it is inclusive frequency distribution. So we have to convert this data into exclusive frequency distribution. We already discussed how to convert inclusive into exclusive. That is, subtract 0.5 from the lower limit and add 0.5 to the upper limit. Okay, so 0.5 will subtract from here, then it would come 99.5, and add 0.5 over here, then it would come 199.5. Okay, in the same way you will find all the exclusive classes. Okay, so that was how to convert inclusive into exclusive. So whenever you are finding less than type or more than type cumulative frequency, you have to see that the data should be in exclusive frequency distribution. Okay, so here we have to first find in exclusive frequency distribution, and then afterwards the first value, see lower boundary point, first value that I have written 99.5. Now less than upper boundary point. First of all, we are considering only less than type. Less than type means less than upper boundary point. Now first class 100 to 199. So in 100 to 199 it would come 99.5 to 199.5, right? Because we have converted it into exclusive frequency distribution. Now less than upper boundary, what would be the upper boundary point? That is 199.5. But less than upper boundary point means it will not include, if we take 199.5, then it will not include other values which are less than 99.5. Okay, which it will not include the values which are 99.5. So we have to include all those data in which the upper class, we have to take the previous class of this class. It means 99.5 upper class, what it would be? First class, that is 0 to 99, right? The first class, that would be 0 to 99, and the second class, see the first class, that would be 0 to 99, second class that has been found out, that is 100 to 199, and so on. Okay, now if we take less than upper boundary point, if we take 199 over here or 199.5 over here, then it will include a less than value to 199.5, but it will not include any of the values that is less than 99, that is less than 100. Okay, so to include those values we have to take the previous class. So over here always make it clear that whenever you are finding less than type cumulative frequency, at that time whatever the class that has been given to you, over here it is inclusive. The exclusive class of this, that would be 99.5 to 199.5. Always we have to take the first value as the upper limit of the previous class. Here it is lower limit, but for the previous class it would become upper limit. Now what is the upper limit of the previous class? That would be 0 to 99.5. 0 to 99.5, or you can write minus 0.5 to 99.5. That would be the previous class. This class, previous class of this class, that would be minus 0.5 to 99.5. So we have to start our calculation with the upper limit of the previous class. Okay, so over here less than upper boundary point, but less than upper boundary point of the previous class. So our previous class, that is 99.5. So we have started the calculation with 99.5, not with 199.5. So remember students, whenever you are starting with less than type cumulative frequency, always you have to start with the upper boundary point of the previous class. Okay. So over here the first class that has been given to you, that is 100 to 199. Previous class of 100 to 199, that would be 0 to 99. And exclusive class how will find? Minus 0.5. So here see I have written minus 0.5 to 99.5. Okay, so upper limit of the previous class, that would be 99.5. So we'll start our calculation from 99.5. So you can see here there are total 10 classes, but over here the upper boundary point, that are total 11. See, you can verify 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Total 11 it would be. always make it clear that compared to the number of classes, always the upper boundary point that would be one more than the number of classes. Okay. So starting we have done with 99.5, then afterwards upper boundary point of the next class, that is the second class for this one, that is 199.5, then 299.5, 399.5, 499.5, 599.5, 699.5, 799.5, 899.5, 999.5 and 1099.5. Okay, so in this way you will get the upper boundary point. In the same way, greater than or equal to lower boundary point, for both the value of the upper boundary point and lower boundary point, that would remain the same. Okay, greater than or equal to lower boundary point, it means 99.5, that would come the lower boundary point, greater than or equal to. Okay, so we have started with 99.5 and ending with the lower boundary point. See, lower boundary point over here, that is this is upper boundary point. Last class upper boundary point, that is 1099. Now the next class after this, what it would become? 1099 to that would be 1199. Okay, so sorry, 1100, sorry, my mistake. It would come to 1100 to 1199. Okay, so after this the next class would come 1100 to 1199. So we have to take, in case of more than type, that is greater than or equal to lower boundary point. Okay, so lower boundary point, that would come to 1100 over here. Next class, as we are taking previous class in case of less than type, over here we have to take the next class, then the last class. Okay, last class over here, that is 1000 to 1099. After that, the next subsequent class, that would be coming to 1100 to 1199. Okay, so we have to subtract 0.5 from here. So if we subtract 0.5 from here, then it would come to 1099.5. So as we were extending, we were moving to previous class. We were moving to previous class upper boundary point. In the same way, in more than type, we have to extend to the subsequent class after the last class. We have to extend to the next class after the last class. We have to take the lower boundary point. So you can see I have taken the lower boundary point over here as 1099.5. Over here it is upper boundary point only. But we have taken the next class. In the next class, this 1099.5 becomes the lower boundary point. That's why in case of less than type, we have to start from the previous class, then whatever the class that has been given to you. And in case of more than type, we have to extend up to one more class, and that lower boundary point we have to take. Okay, so that much things you have to remember while finding the less than upper boundary point and greater than or equal to lower boundary point. Now after finding this value, we have to find out less than type and more than type. That is very easy to find. Always the first value, that will be as it is 0 only, no any starting value, because in the beginning, that is 99.5, less than 99.5, no any value is there, right? So it would be 0. Okay, our smallest value, that is 188. So in less than 99.5, there is no any value. So starting value will always be 0. Then afterwards 199.5. Now you have to add all the frequencies. So first frequency, that is 2. So you have to write 2. Always starting will be with 0 in case of less than type. Then afterwards the first frequency as it is, that is 2. Then afterwards you have to do the addition of all the frequencies. Then afterwards 2 plus 4, so over here 6. Then 6 plus 9, it would come to 15. 15 plus 7, it would come to 22. 22 plus 10, it would come to 32. 32 plus 8, it would come to 40. 40 plus 9, 49. 49 plus 4, 53. 53 plus 3, 56. And 56 plus 4, it would come to 60. So in this way, always it has been told that the total of, the last cumulative frequency should be equal to the total of frequency. Here you can see the last cumulative frequency, that is coming to 60. And already the total of frequency is also 60. So our answer is correct. Okay, so this is less than type. Now how to find more than type? Just as in less than type, you are starting with 0. you have to, in more than type, you have to do the opposite situation. You have to start with the total of frequency. It means total, what is the total of frequency? That is 60. Okay, so you will start your calculation with 60. Now you have to subtract all the frequencies starting from the first one, that is 60 minus 2. So it would come to 58. Now 58 minus 4, it would come to 54. 54 minus 9, it would come to 45. 45 minus 7, it would come to 38. 38 minus 10, it would come to 28. 28 minus 8, it would come 20. 20 minus 9, it would come to 11. 11 minus 4, 7. 7 minus 3, 4. And 4 minus 4, 0. It means totally the opposite situation than that of the less than type. Less than type, always it will be starting with 0. And more than type, always the last value would come to 0. Less than type, the last value that will be equal to the total of frequency, and more than type always starting with the total of frequency. So these things you have to remember while finding the less than type and more than type. Again revising, whenever the data, first of all we have found the class length with the formula, that is C is equal to R upon K. Then afterwards we have found the number of classes, that is given to you 10 classes. We have kept the class length equal, and whatever the classes that we have got that are inclusive classes, that we have to convert it into exclusive class. After converting it into exclusive class, we have found the less than upper boundary point. Now in case of less than type, we have to consider upper boundary point, and in case of more than type, we have to consider lower boundary point. Now less than upper boundary point, it means the previous class, then the first class. What would be the previous class of this class? That would be 0 to 99. Now exclusive class of this, that would be minus 0.5 to 99.5. So we have to start our calculation with the upper boundary point of the previous class. Upper boundary point of the previous class. So you can see I have started with 99.5. Till the last class, total it would be 11. Compared to the number of classes, the number of frequency or the number of upper boundary point or lower boundary point, that would be one more. It means 11 it should be over here. Okay. And the last, that is 1099.5. That is greater than or equal to lower boundary point. Now you can see the last class, that was 1000 to 1099. After this, the next class, what it would become? 1100 to 1199. Exclusive class of this. Exclusive class of this means minus 0.5. So it would come 1099.5. 1099.5. So we have to take the last class or the lower boundary point of the subsequent class of the next class. That would be 1099.5. So we have to carry forward up till the upper boundary point, lower boundary point of its subsequent class. Okay. And then afterwards less than type and more than type. How to find less than type? That is always starting with 0, and then afterwards we have to add all the frequencies till the last total. It should come equal to the number of frequencies. Then afterwards more than type, that is totally opposite. We have to start with the total of frequency and subtract all the values from it, that is 60 minus 2, then afterwards 58 minus 4. Over here you have to add all the values. Over here you have to subtract the subsequent values, and you have to get the last value as 0. Okay, it means your less than type and more than type is correct. You yourself can identify whether your answer is correct or not. Okay. Now this was the new topic that I wanted to explain. I hope you have understood this topic, that is of less than type and more than type. Now moving on to the next question of your exercise, that is question number 4 of the same exercise 2.1, that is on page number 37. Rewrite the following frequency distribution by stating class length and mid value of each class. What is being asked in question? That is to find the class length, state the class length and find the mid value of each class. Okay, so here you can see the data has been given to you in the question that I have written on the board. 0 to 99, 100 to 299, 300 to 499, 500 to 749. You can see there is not equal class length amongst all the classes. There is not equal gap, or lower boundary point or upper boundary point of each class is not having the equal gap. It means class length is not equal in all the classes. Now you can see over here it is exclusive or inclusive. the upper boundary point of the first class and the lower boundary point of the second class are not equal. It means it is inclusive frequency distribution. Okay, so we have to convert this inclusive into exclusive, then we'll find the class length. First of all, we have to find the mid value. Two things has been asked in the question, to find the mid value and to find the class length. First of all, we'll find the mid value. How to find the mid value? We are knowing it very well. Lower limit plus upper limit divided by 2. So lower limit over here, that is 0. 0 plus 99. So 99 divided by 2, it would come to 49.5. Okay. Second one, that is 100 plus 299, that would come to 399. 399 divided by 2, you will be doing then 199.5. In the same way, you have to do the addition of upper limit and lower limit and divide by 2. You will get the mid value of each and every class. Okay. After getting the mid value, first answer we have completed. Now we have to find the class length. Okay. To find the class length, we have to convert whatever the inclusive data into exclusive data. Okay. So here you can see I have counted the exclusive data that I have written boundary points over here. Okay. Because the upper limit of the first class and lower limit of the subsequent class that are not equal. In order to make the upper limit of the first class and lower limit of the subsequent class as equal, we have to convert inclusive data into exclusive data. Okay. So here you can see we have subtracted 0.5 from 0. So it would come minus 0.5 minus add 0.5 in the upper limit, so it would come to 99.5. This we are knowing how to convert inclusive to exclusive. In the same way over here, 100 minus 0.5, so 99.5. 299 plus 0.5, so 299.5, and so on. We have found the exclusive data or the boundary points. Okay. Now after getting the exclusive data, we have to find the class length. How to find the class length? Very easy. That is subtracting the upper boundary point and lower boundary point. What is the upper boundary point over here? You can see over heading also I have written on class length, that is upper boundary point minus lower boundary point. Okay. So upper boundary point, that is 99.5. 99.5 minus 0.5. Again I am repeating, 99.5 minus 0.5. So it would come minus plus. Okay. So 99.5 plus 0.5 would come to 100. In the same way for next one, upper boundary point, that is 299.5. 299.5 minus 99.5, it would come to 200. And so on, you will find the class length of all. And the last column, that is of the frequency, that is already given to you in the question, that I have written as it is. Okay. So in this sum, you have to just find two things. First one, that was mid value, that is lower limit plus upper limit divided by 2. You will get the mid value of each class. And the second one, that I found the class length. To find the class length, I have converted the inclusive data to exclusive data in order to find the class length. Okay. So students, these were the 2 points that we have to find in this question. Now for today's video lecture, I am taking the last question, that is for today's video lecture, that is question number 5. Okay. So let us read question number 5 first of all. From the following frequency distribution, obtain less than and more than type cumulative frequency distribution. Number of errors per page, that is 0, 1, 2, 3, and number of pages, that is 140, 110, 120 and 30. You can see from the data that it is discrete frequency distribution. The range is very small. The lowest value, that is 0, and the highest value, that is 3. It means it is discrete frequency distribution. Now we have already studied how to find less than type and more than type in case of continuous data. Right? Now we have to find the less than type and more than type in case of discrete frequency distribution. That is quite easy. Over here you can see I have written 0, 1, 2 and 3. Okay. Now whatever the data that is being given to you, that is 140, 110, 120 and 30. I am writing the data over here, so for easy understanding, 140, then afterwards 110, then 120 and 30. Okay. So less than type, already we discussed that it will be starting with the first value would be as it is over here. Over here in case of continuous, we are starting with 0. Okay. But in case of discrete frequency distribution, less than type would be the same value as that of the first frequency that has been given to you. Understand the difference. Again repeating, in case of continuous data, whenever the classes are given to you, less than type cumulative frequency first value will always be 0. But in case of discrete frequency distribution, the first value of less than type, that would be same as the frequency. It means whatever the frequency that has been given to you, same you will put as the first value of less than type. Okay. So first value, that would be 140. That is the main difference over here. Otherwise the basic calculation is the same as that in continuous and discrete. Okay. So now 140 as it is, then afterwards 140 plus 110, it would come to 250. Then afterwards 250 plus 120, it would come to 370. And 370 plus 30, that would come to 400. One more important thing, over here there are 4 different values, zeros, 1, 2 and 3. Over here also the less than type value will also come 4 values. Okay. But in case of continuous frequency distribution, the less than type value that was coming to 11. There were 10 classes, but 11 values were coming, right? You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11 values were coming of less than type cumulative frequency. Over here there are 4 different categories or range or number of errors, and the less than type value is also 4. Here there would not be one more value as it was in the case of continuous frequency distribution. Okay, so just you have to start with the same value as the first frequency and then add the subsequent frequencies and get the last value that would be equal to the total amount of frequency. You can see the total of this frequency, it will come to 400, and the last cumulative frequency, that should also come to 400. Now less than type, in the same way more than type, you have to start with the total of frequency. What is the total of frequency? That is 400. So we have to start with 400. Now subtract each and every frequency from it. So 400 minus 140, it would come to 260. 260 minus 110, it would come to 150. 150 minus 120, it would come to 30. It means over here starting value, that would be total of frequency, and the end of the more than type cumulative frequency, that would be the last frequency. Okay. So in this way we have to find the less than type and more than type in case of discrete frequency distribution. The two basic differences there. Always in case of discrete frequency distribution, the first less than type, that would be the same as that of the frequency. But in case of continuous frequency distribution, the less than type first value will always be 0. And the total number of less than type cumulative frequency, that would be equal to the total number of data that has been given to you. It means total number of the errors that has been given to you, that are total 4 values. Then over here also 4 less than type only you will be getting. But in case of continuous frequency distribution, total over here you can see there are 10 classes. Okay, over here there are only 10 classes, but the number of less than type frequency or more than type frequency, that will be getting 11. One more than the number of classes. Okay, so we have understood today, students, that is how to find what is cumulative frequency, how to find less than type and more than type cumulative frequency in case of continuous frequency distribution and in case of discrete frequency distribution. So do revise again from the video lecture. These are very important topics. In the next video lecture, still we'll be continuing with exercise 2.1. Till then, goodbye. Keep practicing. Stay blessed.